Today let's continue with the Tetris game. Basically, if you remember, we have this game that we made. First time we made it work in the CLI, and then we upgraded it to WASM. And the idea is, this could be very well simulated also on an Arduino. So, yeah, yesterday we were able to, if we go in the project, we made this LED controller library. I just moved it out to header library just to make room in our main.c file for more stuff. And yeah, yesterday we were able to put that code on the Arduino and connect it to an LED matrix and control it. So we just stole this code from LED controller GitHub, and it was Arduino, I guess, this thing. And yeah, the only problem with this project is that it's made for Arduino.h. So I wanted to just use the AVR stuff, and we had to rewrite this library in C. Yeah, it wasn't really difficult, so it kind of worked almost first try. The only issue we had was with the variables. We had to make them global for some reason, but other than that, everything worked nicely, right? So yeah, the plan is to now because right now we had just pieces falling randomly on the like running on the LED matrix, and yeah, the plan is to just add input to that. So let's close all of that. So yeah, I started to work on like a schematic for how to do that, and yeah, I guess first thing, let's put everything together just to get that out of the way, and then we can try to program it and see how it goes. So yeah, first let's connect like some power cables to, I guess this should work. Yeah, we have the ground, right? And I guess we can put it on this one, and then also for VCC we can connect it to this one, which is 5 volts. Yeah, we have two grounds next to each other, so we can use whatever. So yeah, we have that connected. Well, I guess would be easier to put it the other way, just because I'll have the USB come from this side, and it's easier to just connect it. Okay, so we have that, right? Let's add the buttons. Like you saw yesterday, we had some buttons. I use this, can stay like this. And yeah, it's better if I just stand here. So let's put some buttons. We can put them anywhere randomly. I guess this one is a bit uglier for some reason, but yeah, anyway, it fits. Yeah, you just have to make sure that hopefully this thing focuses. Yeah, see, like it has, this is how it looks, so that's how it should go. Put them right next to each other, it will be like, I don't know, left and right or something. Then let's connect the like we'll connect the two rails between each other. So let's put the resistors like this between one of the leg and the negative connection or ground, and let's put some red wires, because why not, between positive side like this, yeah, something like that. And yeah, I mean, now let's just connect the power like from this side to this side, just to have it running on both sides. And yeah, I mean, in my schematic I just used, you know, just the port B, or yeah, whatever. So pin 8 and pin 9 for the buttons, basically. That's my idea. So I mean, just some cables, and you have to connect it to the same line as the resistor, so that's the only thing. Then the pin 9 should be like the same on that side. It looks, maybe I can try to use some smaller ones, just so it's not in the way. So this one goes first, and this one goes in here. So yeah, something like that. Well, I guess having the longer ones, yeah, whatever. Let's not think too much about that. So yeah, actually, okay, I'll just use the longer ones, because I just thought about it. We can actually just pull the thing, and even then we can use even longer cables for that as well. I mean, yeah, whatever. So this will be 5 volts because it's green. Yeah, put it there. And the blue one, because it's closer to black, will be ground. Okay, so I mean, now it can get out of the way, right? It's easier to see. So again, let's put this one on 8, and let's put this one in 9. Okay, so now we have to connect, and I'll just connect it through the breadboard, because I think it's gonna be a bit cleaner. So let's just put some connections. Let me just see what I did here when I put, so I set a data pin. I guess it doesn't really matter. Let's use yellow instead of brown. but I mean they are reversed. Yeah, anyway, I don't think it matters that much, so but I would still just do like the 12th, no, that's 13. So pin 12 should be clock. Let's put it like here, why not? Then we have chip select is on pin 11, so like this. Let's put them right next to each other, and pin 10, and when it went in more rough, but it yeah, I think it did. So pin 10 should be data in, right, like this. So we have all the connections done. I mean, it's easier to just copy from the image, but you know. So yeah, I mean, I have two more cables. I don't know why, but which I prepared. But yeah. Anyway, I think that should be everything. Yeah, I realized that in the schematic I put yeah the ground and can be connected from this. We don't need extra cables for that. So this will be connected to the power of the LED matrix. Let's also put like from this we need data. Oh, I mean let's use the same color, but I don't have yellow. I think I don't have yellow. Actually I do. Never mind. I actually have yellow. So let's use yellow for chip select, I guess, orange for data, and white for clock. So yeah, I mean now I'll just now move this a bit like this and bring in one of the modules. So yeah, just connect now VCC, ground. Then I said data will be orange in this case, chip select will be yellow, and white will be clock. So it's a bit cluttered, but yeah, whatever. Let's see how I can try to maybe put this like this, but it's yeah. Okay, fine. This should be okay. And let's take the other one, and we just have to put these ends in the end. Basically, they are also stick to each other, so it's nicer. Okay, so yeah, and when we look at it, it should be something like this, but I don't have a nice way to make them stay fixed in position. That sucks. Well, anyway, we'll just imagine that they should connect, something like that. And this, let's say, just so it's not in the way. Yeah, whatever. It's good enough. So now let's see if we plug it in. Hopefully it doesn't blow up. That would be cool content, I guess. So yeah, right now it's running the old code, so it's gonna just play the same thing on both of them. So yeah, let's test the buttons. Okay, it doesn't blow up. Perfect. So let's now go back to the code, and yeah, first thing I put some to-dos for myself. So yeah, set up the board with all components. That's been done, I guess. Now the next thing that I wanted to do is to make it work with multiple devices, and yeah, let's start by forcing ourselves to have 2 devices here, and now let's think about it. So when we initialize the devices, we actually need to have a for loop like this through the number of devices and initialize each device. So shut down the first one, set the intensity, clear the display, stuff like that. And yeah, that's the first thing that we need to do. Then when we set the rows, let's in fact do something like for int I equals 0, and let's go up until actually we can, here we send like the address is the index of the device, right? And the row is the row. So to compute the index of the device, we just have to divide I by 8, right? Because we have 8 rows on each device. And to get the index of the row, we just have to modulo by 8. And that's everything there. And yeah, when we have game over, let's actually just reset everything. I don't think, I guess, to be honest, that's everything. So board height will be 8. Yeah, and how I fixed this one with board height was I just made this as header only library, and I said, well, I don't care about it, so let's build this. And we have a lot of warnings because I used unsigned, and this is always true for unsigned. It's like a small safety check, to be honest. So let's try to copy this thing, and yeah, I guess I was expecting this thing to work. Wow. Because I'll be honest, I did this one yesterday, just playing around with it, and I haven't saved it just so we could make it right now. That's a bit strange. Well, what I'm gonna do is, just lit up. So let's comment this thing out, and I'm gonna lit up one row here. Let's see the first one, 0B111, and I'm also gonna lit up one row on the other one. I mean, really? Oh, I didn't rebuild it or what? Hmm. I guess I didn't really break anything because I tested this one and it was working, so pretty strange. Let me just, remove everything and let me try to rebuild this. Like, this is what I tested last, right? Like, running it like this. So, let's hard code this to something like this. I mean, it's really weird. When you test something, it works, but then when you test it live, it doesn't. That's what I'm talking about. So let's just lit up, just one. So it should have 2 rows, perfect. And if we lit up the other one like this, it should look like that, perfect. Yeah, I mean, I don't know why it's 4. So we have a 4 like that. Well, I mean, let me just replace one thing at a time. So let me just, like, doesn't work to initialize like this. That's strange. So did what? Am I just dumb? I just do like for int I equals 0. I'll delete this stuff. That works, but if I put this inside and replace this thing with an I, maybe it doesn't like the fact that this should be an u int 8t. That's funny. Yeah, what the hell. Anyway, so yeah, you have, I don't get it, like an int is larger than the uint, so if you have a 0 or a 1, it should fit in nicely on the uint. I don't know how it was not working, but it is what it is. So here, let's not repeat the same mistake, let's make a uint 8t and do I divided by 8 and I modulo 8. So now the board should connect from one another. I think they are put the other way around. Let's see. Yeah, I just have to shift them. I mean, it makes sense because this is the first one. Wait. How can I do it nicely? Man. I mean, I should have also like taken. You know what? If I had some duct tape, that would have been useful. Anyway. And because that looks ugly as hell. So yeah. Anyway, let's just keep it however it stands. But why, like the other way around, it fits better than this. Now I can just use like something to put it in the place. Yeah, I don't have an idea. Maybe if I had longer cables for that, but yeah. I mean, you know, I'll just hold it like this when it's time to test it. I guess it's fine for now. Okay, so yeah, it's now we have multiple devices connected like this. So yeah, it's time to get the input. Man, like the intensity is way too high. Let's play with this thing. See what happens if we make it a bit lower. Because I looked into it like for minutes straight and now I'm blind. So this should be a bit dimmer. I guess it looks the same on the camera, so it doesn't matter. Okay. So yeah, we have the board, we have the multiple devices, and now it's time to get the input. So if you remember from last time, for us to be able to use input, we need to set the data direction register to low. Right, let me check. So in LC we set inside of init, we set this to high. So yeah, it's low. Okay, so we have define. What was this? Is this something real, chat? Define. So we need like left and right. Let's say right is gonna be PB1. Left button is PB1. And right button is gonna be PB0. And let's call them R button and L button. Right trigger and L trigger. You know, like we are having here a brand new console. So let's see. We initialize the thing. Let's also initialize. So let's say LED matrix setup. That's everything for the LED. Let's have Tetris setup, and let's also have input setup. So yeah, for the input, I mean it's already Copilot is already trying to do the job, which is nice. We just have to set the bits to 0. So if you remember from last time, we do this operation like this, and that just sets. So basically this is like an AND, and this is the complement, 2's complement or something. So it makes everything 0, well, it makes everything 1 but the bit that is being set. And I would like to use this one. It looks a bit less crazy. So yeah, and I mean, why we have only left and right buttons? Well, it's because the game just supports left and right movement. We don't have rotation and fast travel for the blocks, and that's mainly because Tetris.h we just try to use only bit shifting and bit comparisons in our update function. So that was really painful, but like, as you can see, it kind of works. It has collisions, and we just use like bit operations on numbers, so that's really interesting. Anyway, we set these pins as input. This is basically pin mode input in Arduino. So we have this thing. Now we need to get the movement. Then we take this thing, like this is the update function. Then we compare, like the idea how we decide that it's time to spawn a new piece is we compare the state of the board with the previous state of the board. And if the board looks the same, it means that there was no movement made by any piece falling. So it's time to spawn a new one. It's pretty easy. Here we are doing the rendering, and if it's game over, we just restart. And at the end, what we have to do here is to set a better FPS. Right now it's just, looking like a Christmas tree light. So let's see. Here we need to get the movement. So let's have a function maybe. I mean, let's put it here. It's so let's have an int left button, and yeah, basically when we are doing inputs, I saw that everyone uses pin B instead of port B, so I just use and yeah, if you think about it, if you do an AND between pin B and the left button pin, like shifts it to its position, like the bit for that, you should get a 1 when pin B is high and a 0 when it's low. So this I think should be 1. Not sure why it was 0 there. And right button is like this. So yeah, basically let's say if we have move, let me think about it. So we could do, let's do like input equals left minus right. So if it's negative, then we press right. Well, it's better to do it the other way around. If it's negative, we pressed left, and if it's positive, we pressed right. And if we press both, then it's gonna be 0, which is move none. So here we are gonna say if input is greater than 0, we move right, otherwise we move left. So I think that's everything for the input. Let's see. So right now everything should fall straight. We no longer have random stuff. But if I press, oh my god, it moves. See? Wait, it keeps moving. I forgot to reset the... Wait, it doesn't move anymore. What? Ah, you have to, yeah, just synchronize with the FPS basically. It's like, and maybe I have to do something like, I thought that's how you get input. Like sometimes it goes. Maybe something's not connected properly. Because I cannot see it going to the right, like numbers go to the right, so but I mean everything is connected, so yeah, see, like going to the left works. Pretty strange. Like this thing is connected properly. Inside of the Arduino the same. And not see it moving in the right direction, so what? I mean, we set the DRB correctly, I guess. So it's not going. So we have PB0 for right, which I mean it's your right basically. From that direction, it's my left. Anyway, and PB1 for moving to the right, or I guess PB1 is moving to the left. Yeah. But we set both of them, right? We set there both of them, and here is like if pin B and L button, we try to move to the left, and Minecraft character moment. So I guess the other thing we can try is to just subtract from one another. Let's see, let's think. So if you do an AND, oh, I'm stupid a bit, because it should be, if it's not 0, it's gonna be like any value basically except 0. So yeah, this should actually in fact make the thing work to the right, also works to the left. That's pretty cool. But yeah, you have to you have to synchronize with the FPS in some way. Would be interesting to see how to, man, just put it more nicely so we can play a game of Tetris. Yeah, I guess first thing, let's change the FPS. So let's have define target FPS 60 and define delay ms. It's gonna be 1000 divided by that. So let's see, delay ms. And probably it's gonna be way too fast. Result of integer division. So let's maybe do something like 20 FPS, because we just move them every frame, so it's gonna be real fast. See, like it's extremely fast, but now it became like an reaction time game. Holy moly, I'm so good at this. Oh my god. Yeah, so what I was trying to say is probably it's gonna be really cool if we use interrupts for the input, although I'm not really sure how to make I lost how to make that work, right? Like it's damn, I mean it's still way too fast, but it's pretty cool. So let's do like 10 FPS. And yeah, I'm totally blind, but yeah, wait, 10 FPS is quite decent, I guess. Enjoyable. Tetris. Oh, doesn't work. Yeah, it works. Yeah, but see, like the input feels really janky because of because we take the input directly like this. So yeah, that's what I'm thinking. Maybe somehow using interrupts. But yeah, I'll just have to play around a bit with the game. Oh my god. I mean, it's way more better than the... Oh, shit. Nah, it's GG. You can't do anything about it. Yeah, like, see how we did it in C. We had another thread which was reading the input, right? So that's how we managed to have smoother gameplay there. We removed it basically from having to like wait for each frame to draw and only then we're able to, let's say, get input from user like in the render, and here we are getting the input in the render function pretty much. So yeah, I guess trying to improve the input would be the next thing. And yeah, like how okay, let's stop. um how I would do it, I guess, is have a global variable as we did in the C version. And okay, so let's remove this. So let's say basically feature game done Arduino. Yeah, I mean, I guess the game is in fact complete. Yeah, it's a pity I don't have a way to hold it in place, but I mean it's prototyping project on breadboard and stuff, so it would be weird to have had like everything prepared. Anyway, yeah, so the game is actually complete. It works decently, I would say. We have unlimited FPS, pretty much. We can just, go mad mode here. Let's put like 120 FPS and see how it runs. Damn, it's too fast. Let's bring it back to 10 FPS and make it look more like a Christmas tree. Yeah, I'm just, what, I'm gonna use another cable to make it sit straight or something, because it really annoys me. Yeah, like maybe yeah, because I don't have enough cables of that type, so I don't know. Anyway, well, one way to actually do it, I guess, because I'm why doesn't it go below the first one? Yeah, I have to. So something like, oh, it disconnected. That's not good. Oh, it disconnected the power and it's was still running. Oh no, yeah, now it's because it disconnected, it only runs on that. So let's. Yeah. Oh my god. What if we do it in the reverse order, and just because putting it like this, it was staying better. But yeah, anyway. So I'll just try to put it maybe. God damn it. Anyway, let's leave it in. I'm not gonna touch it anymore. Okay. So yeah, like trying to use interrupts for the input and having like maybe a global variable for the move that we make, or at least for this input thing, and inside of that interrupt we could maybe set the value of the input, and then in the render function, or I mean this is more like the update, we would have the input already set, and whenever we do one cycle of update we reset the input to 0, and then we have to wait for another interrupt basically. So yeah, that would be my idea of how to fix that, but I mean it still works, right? But yeah, you just have to synchronize the input basically with the FPS, and it's better when you have a higher FPS, obviously. But yeah, also the other thing would be to have some way to it's way too intense for me to think, so bear with me. Yeah, like have a way to hold this thing down with something, because yeah, to be honest, it would look much nicer if it was like in a proper shape thing to hold it, but yeah, like that's to do like when we sell this thing. Right now it's just a prototype. And, yeah, it's not yet the next gaming console, but it could be. So pretty nice, I would say. It actually does the job. So yeah, I guess this episode was a bit shorter because we actually managed to get everything first try, pretty much. So yeah, I mean, let's just obviously the board is like the game is way too easy for me to lose it, so probably we will have to end it without me losing it. So yeah, let's just leave it to lose, and yeah. So yeah, I mean, we actually managed to get multiple LED matrices working, and yeah, put everything together, like the input for the game. We just reused basically the Tetris H library that we implemented. I mean, the input, I don't know why it's still randomly getting input. So yeah, I know. Who knows? Who knows? But yeah, as I was saying, it's really not ideal because it's getting inputs from somewhere, and yeah, we are not really doing anything. But I mean, it still works. It's still a work in progress, I guess. But that would be something to figure out why it was doing the input. But my guess is that reading the input like that each frame, it's not really the way to do it. So yeah, like maybe using interrupts, but I don't know how to do that. So that would be really boring to watch me trying to figure out how to, like, learning how to do it. So yeah, but we actually managed to complete the project, get multiple LEDs working, and yeah, input and everything, put the code, the Tetris .h code, put it on the Arduino, and it worked without any modification. I mean, yeah, we did a bit of modification here, but that was more like a mistake in the code itself. So yeah, but without any, like, having to do anything else, basically. We just took the code that we used on Wasm and in the CLI, and it actually worked. And yeah, pretty nice. We also implemented this header library for the LEDs, but in C. And yeah, I guess that was really nice to have, and yeah, to have the game running. basically. Yeah. So I guess that's all for today, and we'll see on the next one.